Mainly for your lightning and ESD and reverse polarity protection, high voltage protection, regulator, everything is in this. The MEMS sensor is very, very small, of maybe about 1 mm by 2 mm or 2 mm by 1.5 mm. That's all the size. This is a differential sensor, again very big. It is a conventional. We're using a strain gauge. We weighs about 850 grams of different pressures, and based on the reflection, you know what is the pressure in each case. Automatic weather stations. You know, for the weather forecasting, we have the atmospheric pressure itself you want to measure. For that, we have automatic weather station for all that. Or before any launch anywhere, you have to fly some balloons and you want to know the various wind velocity, wind direction, wind pressure and all. For that, they use similar transducers in the balloon before the launch. Such sensors. These are for the launch vehicles, like on the normal principle, ultrasonics, and the flash current sensor. I told you, as soon as it touches the water, flotation system will operate, and one can, go and take off these satellites. A capacitor depletion sensor, one of the very important in cryogenic engine, as the liquid depletes, liquid hydrogen depletes, there is a possibility that there is an explosion, because always hydrogen depletion should not take place. Only liquid oxygen can take place, not hydrogen. If depletes, you have to shut off the engine. For that purpose, a simple process is using a depletion sensor, nothing but capacitive plates. If the capacitance changes, then see, this is the capacitive plate, and this is the, let us say, this is the total liquid, and it is slowly depleting because the engine is firing, and this is the propellant. So you have this green now, but you see the sensors are here. As soon as it reaches there, it becomes red. That means it is like this. Both are 1.1.2. Whereas when it becomes only one plate, it becomes like that, and another one. Just to give you an indication, graphical indication, that anything and everything, even though it is in PF, the ranges, the capacity change, one can detect. All in nanofarads, it is possible to detect, and you can get it. Temperature sensors. Yes, at present you have a bigger temperature sensor. You have seen the commercial sensors or the space sensors all looks like this, very big. It's a thermocouple probe, it's a helium probe, and there's a PRC, platinum temperature probe, like that, for different temperatures. Our present technology, you can make it the 1/10 of this using the MEMS technology, or even a variable where you want to put like graphene. Maybe after there's a talk, maybe Nagarjuna. So he will tell you with the graphene how it can be actually launch pad, launch operation, all that. Yes, all this is nothing but space. It's not only just rocket and satellites, but it is. It's nothing but the micro MEMS is in US, micro system Europe, micro machines in Japan, like that. It's nothing but 3 M's, miniaturization, multiplicity, and microelectronics. To tell you just like that, you will have around 80 to 100 micron diameter. So whatever you do within that, that was approximately, people say that is the whatever the MEMS device. And you see red blood cells around 8 microns, white blood maybe 13 microns, approximate dimensions. So we are talking about a little bigger than that, and less than the half. That is the system. So why MEMS? Why not conventional thing? Yes, as soon as it becomes a smaller and smaller, sizes become less weight, it is having a low mechanical inertia. Automatically it's a low mass. Then you have a minute size, means what? Definitely, even if you, example is normal, I give it, a big glass plate, you just drop from here, definitely breaks. Same time, you take a small piece of a glass, same glass, you take a small piece and drop from any height, it won't break. So, this is one example for that. So here also, the steadiness and the amount of which you can see in the next few slides, how the things are working, even for 1 atmosphere or 600 or 1200 atmospheres, how the sensor is working, you can see that. And the expansion. See, if the bigger one like a door, it's very difficult to, summer or winter closing or opening. But if there are very small things, you can see your mobile covers or something, no problem. If winter or summer or something, you easily put it. The expansion is not noticeable. The expansion is there, it's not noticeable. All that. Lesser space means definitely, previously one item you have to carry, see, your mobile phone, for example, how many SIMs? 1 SIM, 2 SIMs, 3 SIMs, all SIMs are. See, it is possible. No, not one mobile phone. You can have 2 mobile phones, but it is very small, no? Sleek. Your cameras, you see, you have a web camera even still smaller. Fraunhofer has 1 mm by 1 mm cameras. So it's possible to do miniature. You can carry more things and have more, functionalities. All that, yes. So it can be less material requirement and have low cost, and in one wafer, not one, hundreds, 1,000, 2,000 ICs like you are getting, like that you can have the MEMS devices in one wafer, a lot of devices which you will be seeing shortly. So it's like you want to measure with respect to vacuum. So you create a vacuum here and measure. This is a diaphragm. You measure with respect to that. Or you want to keep it in atmosphere. Yes, atmosphere. Same sensor. You diaphragm. Measure with respect to. No, you want a reference pressure. Yes. Or you want a differential between P1 and P2. Keep it open. Measure it. Measure is both. So all this is possible. That means with the same thing you can have the different things.
Is Satnarayana, I currently head BML Munjal University, Gurgaon. It's a university started by the Hero Group, and I think I am attending the conference and will be joining in one of the roundtable discussion on issues and challenges with respect to large area and flexible microelectronics. It's a $1 trillion opportunity of the future in the age of IoT, but unfortunately we do not even teach it in most of our Indian universities. It is very encouraging that RV College of Engineering has taken this initiative 5 years back to start it, and it is one of the few handful of institutions in the country not only just teaching but has even created infrastructure to design and development integrated circuits on glass and plastic. And plus we have today best of experts across the country and even from abroad coming and talking here in the conference. We hope this leads to more expansion of knowledge and also the hands-on experience which is truly needed to create the ecosystem for this technology to take off happens. And I am happy to say that in our own university today we have about 600 crores of investment coming from best of companies in the country, and even in advanced labs like Fraunhofer Labs, Germany have all come together, and we have already in the last 25 months in a new university created enough infrastructure so that students can learn most of these emerging opportunities, disruptive technologies which can enable in health, water, environment, food, or even production and automation for aerospace to agriculture. And so I think it's a very interesting conference and great that it's happening, but this needs to spread to more institutions, and unfortunately, as we said, even the university syllabus does not cover this. Most institutions in the country, even professors in electronics, physics, instrumentation do not know this subject. And hopefully now under the TechUp that RV has been now set as a center for excellence, it will be used to handhold or train more institutions, so that it spreads further and truly this technology takes off. Because in the age of IoT, when 80 billion to trillions of sensors are connected, India cannot expect technology to come from outside. Every college, every student has to do this and create innovative products and solutions which should be made in India. And so it's a very first good step, and it's a second conference in the series, and the conference has grown from its previous edition, so it's very satisfying. And now they are planning to make it national, rotational conference. I think it's even good, and all the best for the conference. It has been very nice interacting with everybody here. Thank you.
I'm Dr. Padmaja, professor in the Department of Electronics and Instrumentation, RV College of Engineering. I'm one of the organizing secretaries of this second international conference on flexible electronics. The theme being wearable electronics. We had around 132 papers, and we have selected around 50 papers. We have a panel discussion, and we have experts from UK and Singapore, as well as from different IITs and IISc. And it was a very, very joyful experience for me as an organizing secretary to carry out this from several months, and it's being implemented now. I congratulate all the coordinators and all the delegates for the paper presentations, and the sponsors, and my principal, my advisor, and everyone. Thank you.
I am Professor Dr. Sufyan Yusuf. I am actually part of Anglia Ruskin University in United Kingdom. This university is based in Chelmsford, Essex, and my main position is the head of telecommunication engineering research group. Actually, this group is including around 13 researchers, and we are doing research in different telecommunication and electronic fields. I, in fact, have sort of around 20 years of experience in doing research in different generations of the fields, and mainly my concentration on electronics, telecommunication, security systems, active noise cancellation, cloud computing, SDN networks, and also about managed, which is actually mobile ad hoc mobile networks. We have different projects with Europe, we have different projects with SMEs and industry in UK. We have also different projects with India, so we are connected with a big UK project with Madhya Pradesh IITM actually for 2 years. We are finishing this project in January, so I'm coming back again in January. At this time, I was invited to RV College of Engineering. This is my second invitation to them. I had been contributing in their first conference in 2012 about really internet computing and so on. Now the field of the conference is about wearable electronics, which I have done lots of research in. I have 2 students working on this field. We have designed some batches, and my covering of this talk will concentrate on wearable technologies, where they are, where they have been. Are we in the first generation? Are we in the end of it? Are we coming to a new generation? What are the benefits of these? Are they really taking position in the market? Are they struggling? I can say my opinion about all of these, but I can say that the technology has achieved lots of benefits, but it has not been welcomed by really customers. It was not really making the money which was aspired for by big really sharks in this field, especially Alphabet, the owner of Google, and also for Microsoft, and also for China and Japan and other countries. They have made a huge amount of patents. They kept it secret, thinking that they are benefiting financially out of it. They have produced a huge amount of equipment. It didn't really attract many people, although I should say the truth that they have been working well in the health sector. In the fitness sector, they work much more than any other sectors, except they are not more than the health sector anyway. But people, after some time, when they buy it, they will just lose the interest for some reason, we don't know. Mainly because of the charging problem, and mainly sometimes miniaturization has become so small to charge. But also there is a look factor, the look factor that they should be matching, when we are saying wearables, they should be matching what people are wearing, like bracelets and things, so they can be hidden. No one wants really to put something in his body and then make the body not looking good, especially someone putting something in his ears as if he is really a deaf or whatever. So the other problems is the technology itself still didn't solve the battery problem. The battery is a big thing. It's not miniaturized, and also in some cases the battery can be really finished in 3 hours. And sometimes the problem is because also they are finishing the battery of the mobile phone. So I can say the truth that this technology has not started to take toll at this time, but I expect there are specific items about really virtual reality and about Google glasses, which will make the eye recording what it sees everywhere. These things in the future, we call it the bio-eye, maybe are welcomed by many people, and specifically in the military sector. So I hope things will become different. We need still more miniaturization. We need to solve the problem of how they look. We need also to make them cheaper. Unless we make them cheaper, I don't think they will take a big part in the market.
And do you feel so at this point of time, so where this stand-up India, digital India, make in India, so many things are happening. This large area, flexible microelectronics, the topics like this, so have to be given more awareness, and especially for India, so to develop many other advanced things.
Yeah, the purpose of this type of international conference is mainly to give more awareness to the people. Even though the technology they are going to develop, and maybe in a span of another 10 years or 15 years, it will be very common to reach the common people. But now more awareness, that is possible only through this type of international conference. And this is organized, last year was the first year conference, and this is the second conference organized by RV College of Engineering. So in this regard, our professor has come here and he is really going to talk on the main topic, wearable electronics, and his talk will be very, very useful, and it is going to give a lot of awareness to the audience, and this audience also very much interested in knowing a lot of awareness in this regard.
In regard of the 20% of people, they know really about this technology. Still, knowing about the technology, which is really including the hardware and the software working hand by hand, still didn't solve their actually critical needs. if I go to the gym myself, I don't think I have to wear something to control how many bumps my heart did and how many minutes I stayed in. I'm enjoying myself there. I don't know how many steps I have run when I'm running in the machine. So some people look to it as extra thing. Except for the health matter, they have been very crucial. We need them to do more. And actually they're solving many problems for diabetics people, for people with the heart problems, for people with children with temperature problems. Some people who have a problem of pulse, like the pulse is too high, you can't leave them and check them every sort of 1 hour or 1 day. You have to check every second. You can't have the hospital taking people these days continuously. So you give this equipment to them, and these can be monitored by doctor from far. In many cases, really, you need these things to help. I know a small child who is diabetic at 10 years old. They have attached a pump for this to work automatically. Whenever the blood has more sugar, then the pump really works automatically. In some cases, there are lots of things which we can use for tourism, like if you travel somewhere and you have your camera, rather than taking photos, you can have automatic thing, you can put it in your head. We call it HUD actually, which means head-up display, which can really automatically take all the videos everywhere. There are some handy issues. For military, they need it more actually, because these sensors will in some cases help the people to carry more weight and help them to have more stamina.
Yeah.
And really, I would support the idea of using them for military people. In some cases, there is a protection situations. So I'm thinking that in the health matter, in military matter, it's crucial. It will work well. The Indian community, they know about it, and I think they are still more expensive than the average person economies. I know many people, they have bought it even in India. I know myself personally people in the UK bought it. I don't think they continuously fond of it, they left it after some time. In some cases they can be dangerous, because a lady who bought a Google Glass, she was really attacked by people, and then they took the Google Glass because that costs around $2,000. So there can be some limitations and restrictions. I don't think by the moment I can say that we have finished it from first generation. We are still in the trails of the first generation.
Very correct. I am Dr. Sridhar, Director RV Cognitive Technologies, and as a visitor to this conference, what I find, this conference is very nicely done on the wearable electronics, and it is towards Make in India concept only. It is conducted in RV College of Engineering. And this is the second conference organized by this college, and every speaker was selected for this conference from abroad and also locally, and they have given wonderful talk on the related topics, namely wearable electronics, and students also enjoying everybody's talk, and about 52 papers I think, as said by Professor Rajarao, they received, and some 25 papers have been made in the form of proceedings, and they will be published in elsewhere journal. And I find this particular conference will be a kind of eye-opening to the people in terms of awareness on wearable electronics. Otherwise, most of the people, they know what is electronics, but most of the people, they do not know what is wearable electronics. So definitely this conference is a very good platform for very good interaction on wearable electronics concept understanding, and thereby the young students, they can also focus on research oriented topics, and they will show more interest in doing, because it has got direct utility value to the society. And here we are also discussing the pros and cons of wearable electronics. That means what are the harms it will create, and even though the harms are creating, and whatever the troubles the wearable electronics are creating, we can always think about the remedy for that, so that in the positive way, the wearable electronics, if it is coming to the market in a cheaper way, of course it may take maybe another 10 years or so using indigenous way, and definitely it is going to be very useful for the society. And if you look at originally when the mobile was introduced, the mobile phone was very big. It was not phone, it was only a device, and people were using that. It was very high also. Only some people who are enjoying luxury only, they were enjoying the mobile. Today, even ordinary fellow like milk fellow and even the shopkeepers and anybody can purchase mobile at a cheaper rate. So similarly, getting these wearable electronics components which are utility oriented for the common public, it is very nearby. This is what I want to conclude. Thank you.
Okay, I am Professor Uttara Kumari, Professor in the Department of Electronics and Communication Engineering, RV College of Engineering. And also I am the COE Center of Excellence Macroelectronics Coordinator under TechWeek 1.2.1 program. This Center of Excellence Macroelectronics is established under TechWeek 1.2.1, which is a MHRD World Bank funded project. In 2013 it is started, and almost 500 lakhs is sanctioned to establish the Center of Excellence in Macroelectronics or large area flexible macroelectronics. So the objective of the Center of Excellence is to enhance the knowledge in the area of large area flexible microelectronics. The main specific objectives of this Center of Excellence are design, development, fabrication and characterization of various thin film transistors and sensors using amorphous silicon, polymers and metal oxide semiconductors. So with this Center of Excellence, almost 9 departments are involved in the Center of Excellence in the areas of materials, bioscience, biomedical science, communication and sensor development, solar cells and different areas under this particular one. So, as it's an emerging topic, flexible electronics. The faculty from various departments have formed their interdisciplinary research groups, and they are developing projects and prototypes on flexible electronics domain. So, after conducting various workshops, motivation sessions, and technical talks, the first international conference was organized in December 2014 on materials, devices and systems. With that idea of, after taking the inputs from that conference, we have developed various products and prototypes, and which is applied for patents. Almost 15 patents are applied in this particular area. So almost 100 faculty from 9 departments are involved in this Center of Excellence project, and 10 to 13 prototypes have developed. In that one, say 7 products are prototypes are applied for patents. So with that area, with that knowledge, whatever we gained, we thought we'll go for a second international conference, especially focusing on wearable electronics. So in this particular conference, we focused on wearable electronics. So experts working in the area of wearable electronics across India and the world, we could get it, and we are happy that we have professors from Singapore, UK, IIT Madras, IIT Jodhpur and IISc, we could IIT Kanpur, where National Center for Flexible Electronics are working. So we could get professors from various domains and to get the knowledge in this particular conference.
The rigid electronics, right? So it's nice to understand how the transition is happening from rigid to flexible, right? And no better than Anil to kind of give you that view, right? Anil, go ahead.
Thank you for the industry persons to coming here and sharing their experiences.
I am Professor Raja Rao. I am the chair of this conference in large area flexible electronics at RV College of Engineering. This is the second conference we are holding. Yesterday we had a tutorial, pre-conference tutorial, and we had talks from Alphonse from Singapore University, and then we had two sessions from the industry persons, and then we also had a very interesting visit to Sense Lab in IISc. And today was the inauguration day for the conference, where we had an inauguration by Professor Gupta from the IIT Kanpur, from the Flex Electronics, National Center for Flex Electronics, and we also had a session from Professor M.M. Nayak from CSE Center IISc. And we had a very good panel discussion today about the challenges that we are going to face in the flexible electronics and what is the Indian scenario, because people are talking that flexible electronics is the future and flexible electronics is going to take India to the next level. But are we ready to do that was the panel discussion, and it went on very well. And tomorrow we have two more sessions, one by Mr. Yusuf from UK, and he will be talking on wearable electronics. And then we also have session by other eminent persons. The paper presentations are happening today as well as tomorrow. Totally there are 52 papers that will be presented by various presenters. My hope is that this particular conference is going to help in networking with other institutions, and students as well as the researchers will have a very good opportunity to link with others, not only in India but also in Singapore as well as UK. I hope that this conference is going to take us to the next level. Our next conference, we are thinking to make it as a rhetoric conference, and maybe we will have this conference in one of the institutions, either IIT or in Munjali University next year. So I wish that we have a good interaction and we go ahead. RV College of Engineering has done a lot of work on wearable electronics, started working. Some work has been done on TFTs, sensors, and health systems. And we have also done work on amorphous PV cells, and we hope that we will be able to do much more in the flexible electronics.
This is Professor K. Subramania, Principal of RV College of Engineering. We are conducting the second international conference on large area and flexible electronics, and this is the second time we are organizing. The first one was in 2014. Under TechUp World Bank funding, we have received 5 crore rupees for Center of Excellence in large area and flexible electronics with a theme on macroelectronics. And under this we have established a lot of infrastructure in the college, and a lot of papers have been published, and also the patents have been filed through the work carried out in the areas of healthcare, sensors, and we are trying to work in the area of transport also. And approximately around 50 faculty members of the college are involved in this interdisciplinary research, which is in line with the vision of the institution in terms of enhancing quality of technical education by interdisciplinary research and innovation with a focus on sustainability and inclusive technologies. So in line with this vision, we are today organizing the second international conference. Yesterday we had a pre-conference tutorial which was very well received by the participants, and we have speakers who have come from Singapore, UK, and the premier institutions in the country. In the afternoon, as a part of the tutorial, the participants have visited the Center for Nanosciences lab in IISc. So today it all started from inauguration, wherein professor from IIT Kanpur tried to give the overall development of macroelectronics in the country and what are the challenges ahead of all the people who are working in the area of nanoelectronics. Then we had a panel discussion in the afternoon to look into the challenges and the opportunities and the roads ahead for people who want to work in the area of large area flexible electronics. And we have received almost around 50 papers for presentation, and this has been categorized into 4 tracks, and it will be conducted parallelly, and we have called experts to evaluate these paper presentations of the various participants, and there are some research scholars also in this, and we have plenary sessions on both the days, and this will enhance the knowledge in the area of large area and flexible electronics, and this is an in thing in the market, and the many consulting agencies have predicted there is a lot of scope for this in 2020, 2025 and 2030, and India most probably would become the leader in this area of wearable electronics, which could be in the area of entertainment, the movies, the smartwatches, but it could be in the area of structures, it could be in the area of agriculture, transport, and I think the sectors are boundaryless, and the application would be there in various places. Since last year we have conducted 3 international conferences in continuation with what are the 5 centers of excellences we have arrived at in Harvey College of Engineering. We are also conducting a national conference during February on intelligent transport system. The theme of the conference is Better City, Better Life. And we are trying to look into the technologies, the processes, the systems, and the capacity building in this area of transportation systems which are intelligent, and this is going to augment the Made in India concept, and is also going to augment the design and development of smart cities, because there are 3 technologies which are very, very important if somebody has to develop a smart city. These are called as wet technologies. It is water, energy and transport. These are the 3 essential things in a smart city, and we are trying to focus on transport in our national conference, and I also wish many of the viewers of this would be attending to this conference. Maybe in another 2 weeks we will be coming out with all the details about the conference. I hope this conference will add a lot of value for the people who come from different parts of the country, and I also hope that there will be a good interaction which happens between all the participants and the delegates, and that's all from my side. Thank you very much.